To solve a linear inequality, we're going to proceed in the same way that we would if this were a linear equation. If this were a linear equation, what we would want to do is simplify both sides as much as possible. Then we would move our variable terms to one side and our constant terms to the other side. And the last thing we do is either multiply or divide to completely isolate the x variable. And it's at this step when we have a slight difference in our process. If we have an inequality and we multiply or divide by a negative quantity, we would need to then switch the direction of the inequality. So let's walk through these steps with this example. There's nothing else we can do to simplify the left-hand side because neither of those are like terms. But on the right-hand side, we could distribute this 2n and combine like terms. So let's copy-paste the left-hand side and distribute the 2 into the right-hand side, which is going to give us 10x plus 8 minus 3. Now we have two constants that are like terms, and we can combine those two on the right. Again, we'll continue to copy-paste this left-hand side and keep the entire problem with us in every step. Now, we have 10x is our variable term on the right, and plus 5 is what results from positive 8 minus 3. And now that both sides are simplified, it's time to move our variable terms to one side and the constant terms to the other. Let's take the 10 to the left, getting our variable terms to the left-hand side, so that we get negative 3x. We still have plus 15 is greater than or equal to. The 10x is canceled out, and we now have just the 5 on the right. If we move our constants then to the right, we'll be subtracting 15 from both sides. So these 15s cancel on the left, and I have negative 3 is greater than or equal to negative 10. Now it's time to either multiply or divide in order to completely isolate the x variable, and we do that by dividing both sides by negative 3. Notice that when we divide by a negative, that's going to cause the direction of the inequality to switch. So on the left-hand side, the 3's cancel out, so that now we've completely isolated the x. And on the right-hand side, we have negative 10 divided by negative 3, which is going to give us positive 10/3. But because we divided by a negative quantity in this step, it causes the direction of this inequality to switch. So now it's time to express our answer, and we've been asked to express it in both interval notation and in set builder notation. Let's start by first graphing this solution set on a number line. And it doesn't have to be too fancy here. We'll just focus on this one point of interest, 10/3, and we want to look at the x values that are less than or equal to 10/3. So we do include the 10/3 with a bracket, and we're going to be then shading to the left of that bracket, which gives me the x values that are less than 10/3. Having the graph available sometimes makes it easier to figure out our interval notation, which again starts with the smallest element in the solution set, which in this case is negative infinity, and the infinities always get a parenthesis around them because they are not able to be included. And then we finish with the largest element in the set, and in this case we do include the 10/3. So this is our answer in interval notation. And in set builder notation, we begin with the curly brackets to say the set of all x's, vertical bar means such that. We then close those curly brackets and leave space for a criteria, and the criteria is the inequality version of our solution. So we'll say x is less than or equal to 10/3 in here. So we would say this is the set builder notation of our solution set.